Hi, good morning, everyone. I hope all of you are doing well. And I'd like to start with thanking all of you for your time. So, today we are here to learn a little bit about laser scanning. I believe a lot of you might have been users of laser scanning in the past or might have been using this technology since quite some time. I myself have been involved in laser scanning since 2012. And in the last 10 years, I've done a variety of projects, both in services as well as sales. And projects have been ranging from various sectors like heritage, maybe 3D laser scanning and mapping of Taj Mahal, to Rashtrapati Bhavan, and then some offshore refineries, offshore rigs, and at the same time to monitoring the glacial melt at the South Pole. So laser scanning has a variety of applications. Uh, and then I'll give a brief intro about myself. I'm Pranay. Currently, I'm working with Trimble, looking after the geospatial solutions, majorly into this laser scanning segment. And at Trimble, we have been innovating of this laser scanning technology since quite a while. And the technology has come very far from what it used to be 10 years ago and what it used to be even earlier. And at the same time, we have been trying to reduce the workload of the people who have been doing the laser scanning, or maybe increasing the efficiencies on the field, and how to use the data in a more usable manner, and how to make laser scanning accessible to everyone. So before we go any further, I'd like to give a brief introduction of that, what exactly is laser scanning, how it is going to work, how it is going to help us, and what we will actually do with laser scanning data. And at the same time, I know that you guys have been attending these webinars since last few times. Uh, so after this, we'll build a little bit of the brief of that. Okay, what the other webinars will bring in for you, what you have to follow. And my own motto is that ki by applying the technology, it has to make your lives easier. So that is what we'll majorly focus on today, and alongside what innovations we have made with the newer equipments. So we shall start with the presentation now. So introduction to 3D laser scanning, that is basically some advanced surveying. Laser scanning has evolved from traditional surveying methods only. Like a lot of you might have been using traditional surveying methods, whether it is a simple distance measuring using a distometer, or using chain surveys, or even simply measuring the elevations using a variety of technologies by different companies. And like when we say of like what is the total station, it has evolved from a theodolite. So now we used to be mechanical, and then there were electronics, then there are robotics. Now there have been solutions for one-man survey as well. So while we were taking one points at a time, with laser scanning, we can take multiple points at a time. So we will start with what is laser scanning, then why laser scanning is important, then what the workflow it has to be followed, and then we'll go for that what Trimble has to offer in this laser scanning segment, and what are their applications. So this applications part is bit more important, because the technology is there with since quite number of time. But where do we actually have to use it, and where will actually save our time, where will actually save our cost? That is a bit important for me. So we will start with what is laser scanning. So laser scanning is basically, the laser scanner also sees everything what your eyes have been seeing. The only difference is that when we take a photograph, or when we take a laser scan, a photograph is a representation that okay, I am able to see it in a digital world. But in laser scanning, we go one step further, that okay, you have brought your objects to the digital world, but you would should be able to get the information on its geometry, what is its shape, what is its appearance, and most importantly, everything should be measurable. You should be able to measure every single individual coordinate, and at the same time, you should be able to measure that okay, what is the surface, or how my surface is looking like, and how I'm actually using the surface. So bringing it in a full-fledged 3D digital environment with all the measurement capabilities, or the distance measurement capabilities, is laser scanning. And when we talk of laser scanning, this word we hear quite a lot of times, that okay, what is lidar? What is lidar? There is lidar technology. There are airborne lidars. There are mobile lidars. There are terrestrial lidars. So LiDAR is basically a combination of light and radar, and we call it as light detection and ranging. Like a radar is sending certain waves to an object, and then radar is trying to read that, okay, what is the signature, what is coming back. So a LiDAR is simply emitting the light, and it is reading back that, okay, what my light is seeing, and how we are going to use that. So this is one example of traditional survey versus laser scanning. So you can see that on the right hand side, we have a traditional total station which is measuring 1 point at a time. And we are able to see that, okay, it has measured a certain number of points. And on my left hand side is a laser scanner. So we'll try to learn a little bit difference. So when we talk of traditional surveying, it is still measuring 1 point at a time. So, but just after even all this measurement, at times it is difficult to identify that, okay, what are these dots? But at the same time, if I connect all these dots together, then I'll be able to actually see that, okay, this object is actually a bridge. So when we talk of a laser scanner, so it is not just collecting 1 points. A laser scanner will generally take care of points. It can take points, say 30,000 points a second, and it can go all the way up to 2 million points a second. So that, and every single point which you are seeing over here has its own coordinates with northing, easting elevation, or in simple terms, x, y, and z values. And since we have a collection of so many of the points, that is the reason we are able to see this object. And this collection of points which we are seeing here, that we refer to as a point cloud data. So there are two types of laser scanners. Like one, either we can classify it based on the principle, or either we can classify it based on the range. So generally, laser scanners are classified in two ranges. One is the short range, and another one is the long range. So short range can go from 50 meters to 80 meters, 150 meters with the newer technologies, and long range scanners, which generally can go from 350 meters all the way up to 6 kilometers of range. And when we talk of type, so there are two types. One is the time of flight laser scanner, and another is phase based. So time of flight is a fairly simple principle. Inside of the laser scanner, there is a laser emitting source. Uh, the laser is emitted from the object, it strikes an object, and it comes back. And the laser scanner records the time taken by one particular beam to strike an object and come back, and it is doing it for all the millions of beams which are being sent out of the laser scanner. We all know that speed of light is taken as a constant. Laser scanner is recording the time taken to strike the object and come back. And it's a very linear relation between speed, distance, and time. We all know that speed is equal to distance upon time. Uh, Speed of light is taken as a constant. We can take it as 3 lakh kilometers per second. Time we are recording, and accordingly, if we multiply speed by time, we have the distance calculated. So, and the another type of scanners are phase-based laser scanners. Phase-based laser scanners are generally little bit more precise as compared to time of flight based. Phase-based scanners do not rely on the simple trigonometry of the light striking and come back. They are constantly emitting a beam of laser energy, and the laser energy beam is emitted, the same beam is striking an object, and it is come back. So phase based scanners are actually recording the phase shift of the frequencies between the emitted wave and the light wave, and eventually that's how they give us the distance. And the distance can be translated into a 3D world in terms of 3D coordinates. Again, you can call it northing easting elevation, or you can call it xyz. And when we have a collection of all these infinite XYZ values or millions of XYZ values, we get the actual geometry of what we have scanned. And when we talk of taking measurements in 3D, so like if you are standing from one place, or you are just seeing in one direction, you cannot capture everything. You have to look all around you. You have to look above your head. You have to look below your head. That, okay, what is there? So similarly, a laser scanner also sees all around. So for that, the laser emitting mirror, it has to move into a certain way. So the moving mirror, it could either be a rotating polygon mirror where the mirror is rotating full 360 degrees, or it could be oscillating mirror wherein it is oscillating between, say, certain angles, say let's say between 0 and 120, or between 60 and 120. And so while the mirror is rotating, you are still seeing in one direction. And in order to take 3D measurements, the scanner must also either rotate or it should move. Rotate means when we talk of the laser scanner, so the scanner is rotating on two axes. One is a vertical pivot in which the scanner is rotating horizontally, and another is a horizontal pivot in which your mirror is rotating vertically. So, like when you take a combination of these two, you are getting a sphere form of a data, or my scanner can continuously move. Like for instance, if my scanner is mounted on a drone, so my drone is continuously moving, even though the scanner might be looking in one direction, but when it takes a moving, it is giving me a depth information, and I can go much further as well. And then we'll come to like why exactly laser scanning. Like there have been methods where people can take certain measurements manually, or there have been methods where people can simply use a traditional method for a survey. So why laser scanning is important? So in a traditional method of survey, as we learned, wherein we are capturing limited information, when we talk of a laser scanning, we are capturing a lot more information even as compared to photos, because though photos will tell you what all is there, what all is not there, but photograph will not allow you simply to take measurements. And it will also, laser scanning will also reduce your time taken to continuously travel to site and come back. Once you have done the laser scanning, you have a virtual site all in front of you. And once this virtual site is there, it is on your system. You can use it for your design, you can use it for your engineering, and you can use it to plan your construction. And at the same time, this data will integrate to either your 2D drafting software, whatever you might be using, could be AutoCAD, could be anything, or it will also integrate with your 3D modeling software. Like whether your application is simple CAD based application, or you need to do a full 3D model, or you need to do BIM term is being widely used today. So in order to do an actual as built 3D model information, laser scanning is the only solution we have. So where exactly we can use laser scanning? We can use it for retrofitting projects. So for instance, if I have a plant, it might be 30 years old, and some new designs have to be changed over here. When old design, and so you have to do planning for a new design. In order to do that planning, you need to get the actual accurate as built information of that site. So then you can do retrofit. You can do at a brownfield project, again revamp jobs, hard to access sites. Like I'll take an example that since last few days, or since last month, we have been working. We have been seeing in the news that Chenab Bridge, the highest bridge over there, it is being constructed now fully. It has been built together. Railways has built that particular bridge, and now you try to imagine it from the very beginning. It's a very deep valley, and before building any bridge or before doing any construction, the surveying is the first and foremost application which you have to do. So how will you actually do a survey if you cannot go to the uh, other side of the valley for now? So like in order to do that survey in that particular project as well, they use long range scanners to capture all the terrain information, get a terrain model in 3D, and then do their planning. So this laser scanning and this surveying is the one which allows you to make that particular planning and allow your design to actually be built on the field. So you can bring your virtual site to office for better planning, and the faster data capture, it also reduces your costing and timeline data from data collection to project execution. Now imagine if some person was going there, he would have to walk the entire terrain, taking one point at a time, one point at a time. It would have taken a lot of time. Whereas while laser scanning, all this information you would have been able to collect it in a day. So when we have a 3D instead of a 2D points or certain number of drawings, it provides a much detailed view for planning, and there is much lesser risk for human error. Laser scanning provides you accuracy in millimeters level. It is an efficient means of working from maintenance to modifications. And at the same time, laser scanning is the technology which is bridging the gap between designers and the people actually executing the construction on site. We'll start with the basic laser scanning workflow. Like first step is simply scan an object. Second step is called as data registration, wherein if you have taken the scannings from a multiple positions, but you still need to bring all of those together into a singular coordinate system and stitch it all together. And the third step is that then you can use that data based on your application. If it is a 3D model, you use it for 3D modeling. If it is for a 2D drafting, you use it for 2D drafting. If you want to generate a DTM or a topographic map or a contour, then you can use it accordingly. So before we actually do that, first step is always the planning. So I'll take example this particular stadium over here. So this had to be revamped. It was getting old. So planning was that first I'll go, I'll visit the site, I'll see that okay, what all is actually there, what all is not there. what are its tentative dimension of the stadium, what is its length, what is its breadth, what is its height. Then accordingly I'll plan that, okay, where my laser scanning has to go. And to plan that, I'll do a reconnaissance that, okay, which are the areas where the structure is failing in this particular case, where there is a lot more rust, where the structure might have sagged a little bit. So I'll do the planning, I'll identify, and in those, and these are the areas where I need maybe a much higher level of details. So I'll plan more scanning over there as compared to other. Like I might be moving the scanner 30 meters at a time. In this particular place, I might move it 5 meters or 4 meters at a time as well to capture as much detail as I want. Then my process is control survey. You can also call it as a technology to use georeferencing. When you are doing the site or when you are surveying a site, what are the site coordinates, or if it is in, or where exactly can you locate that site on Google Earth? To get those global coordinates, you need to do a control survey, and those coordinates can also be transferred to your laser scanning data right on field itself, so that your data is georeferenced. If you, whatever are your site benchmarks, you can transfer them to your laser scanning data. Then comes your process of scanning and registration. So earlier the process used to be like that. The people who are actually doing the laser scanning, they will take all these scans on the field. They'll come back to office, and then another team will stitch all these scans together. Or the people might spend some more time at the night to stitch every single scan together. That okay, that this is there, and then they'll find out that okay, there have been certain gaps. You missed something. They'll go back again and then do the scanning once again. So what is happening over here is that with Trimble innovation, what you can do, as you are moving your scanner along the side, as you're shifting from one position to the another, the scanner will automatically find out that okay, what was my previous position, what is the overlap I have, and it will do this process for you right on field itself. And this will allow you at least 40% of time savings by using other laser scanning methods as compared to the innovative approaches of Trimble. Then comes the process, the post processing, generation of final outputs like 3D model. I can generate, I can do a DEM, I can do a DTM, I can draw a contour map, I can draw a 2D drawing, I can make a floor plan, I can make an elevation drawing, I can make a facade drawing. So that is the process. And after the process, who is my end user? How is he consuming the data? So in this particular case, we have taken an example that on your screen you can see that okay, we can see 3D model, and at the same time we can show that there is some 3D scan as well. So in this particular place, some new equipment had to be added, and the new equipment might, and with your design, it might clash with the site conditions, or it might not clash with the site conditions. In order to do the better planning, it was laser scanned, and laser scan was overlaid over the design model to identify that okay, where my information is clashing, where it is not clashing. If I need to make certain changes on the design, I'll make it right here itself. Because imagine, had you sent this for fabrication and then later you found out that okay, this is not the right dimensions or something as wrong has happened, it would take a lot of time, it would cost a lot of money. So in order to avoid this problem in the first place, that's why the laser scanning was done. And then you'll have to plan how your end user is actually consuming the data. So now coming to laser scanning at Trimble. So at Trimble, we have a variety of laser scanning solutions. So our scanners might range from a range of 80 meters all the way up to 600 meters. So we'll concentrate a little bit more on the X7, Trimble X7 laser scanner. So Trimble X7 is like, you can say that in laser scanning, it is sort of the new kid on the block. But what it is that it is simple, smart, and professional. And how simple is that? Keep like if a user starts to use this particular solution, within a day he would be able to use it precisely. He'll be able to actually see that what is he getting, what is the level of accuracy he's getting, and so that his life would become easier. It is very easy to use and very efficient in field data collection, and at the same time it is a quality instrument. For instance, when we talk of these surveying instruments, so generally what happens, these surveying instruments, they say that okay, you have to get them calibrated every year. Even for total station, people get them calibrated every 6 months. So, but what this equipment offers is that it will never need a calibration until and unless you break it, of course. It has an inbuilt collimator or the device which is necessary for calibrating it, and before every scan, it will calibrate itself. It will give you the calibration report on field itself, so that you will know that okay, you are confident that okay, my data will be correct. And when we talk of simple, it is as easy as pressing a button. You have a scanner and you have a Windows tablet. You simply start the laser scanner from the tablet. Use the tablet as a controller. You can use any other Windows PC as a controller, and then simply start with scan. Whatever it is scanning, instead of relying that going back to office, you are seeing right where on the field itself, that okay, where it has captured, what it has captured, and if needed you can take certain additional photograph. You can add notes to your field as well. And we talk of smart, so we talk that okay, it has the automatic calibration, and it has a registration assist of full automatic registration. And after registration, it will actually refine your registration as well for you. Refining means, for instance, if I have taken few positions like scan number one, scan number two, scan number three. Scan number one is linked to scan number two. Scan number two is linked to scan number three. And so on. Scan number three might be linked to scan number four. So, but at the same time, I might find that okay, some portion of scan 4 is actually common with scan number 1. So instead of you defining it all the time, the scanner will find it on its own, and it will create all the links together and increase your accuracy as well. And another thing when we talk of surveying instruments is that okay, you need to level it. There is a bubble, you level the bubble, and then at the same time, always you need to level it. Otherwise, your data might get tilted, or it would get um, or it would get distorted, or you might not be able to use it. But with Trimble X7, leveling is never required. You can tilt the scanner up to 45 degrees, and your data will still be level. At the same time, what other laser scanners don't allow and Trimble X7 allows is single point measurements like a total station. So it has a single point laser as well. If you know the coordinates of one particular place, you can directly point your laser to that point. And using the controller, you can add its value, and your data is georeferenced on field itself. Either you can use it with tablet, or you can simply use it with one button. Press the button, it will scan. Press the button, it will scan. And then if you bring it to the software, even after your surveying is done, it will still do the automatic registration to help you and save your time. And another thing is that it is IP55 rated, in that the mirror is hidden inside a black casing, so that it will work from minus 20 degrees all the way up to 50 degrees. And at the same time, it has an IP55 rating. It means even if there are mild showers or very small amount of rain and all, you will still be able to scan, and you will not lose your time. And trust me that during monsoon seasons, it happens quite a lot of times that the work is stopped because there are certain mild showers. But with Trimble, it doesn't happen. And at the same time, like we know that light is being reflected. So different colors or different materials are reflecting light differently. So where laser scanners struggle is that if my surface is too dark, if it is a black surface, black is absorbing all the light and not reflecting anything. Or if my surface is too shiny, then the light reflections might get distorted. So what this is actually doing is that it has a high sensitivity mode as well. So it will effectively capture the data on the dark surfaces and the reflective surfaces. And then the full data redundancy. Okay, you have a tablet, your tablet can die on the field or something happened. So, but you will still not lose the data. The data is always stored in two places. One is an SD card, which is on board the scanner. And second thing is the data is stored on your tablet as well. So there are certain feature overviews like automatic calibration, automatic registration, and survey grade self leveling with 3-second accuracy. You can use it from zero point 0.6 meters to 80 meters of the range, and its 3D point accuracy is around 3.5 millimeters. You can use it with a Wi-Fi. You can use it with a digital cable, and it uses a time of flight, which is an expensive technology to use. And the frequency of this particular scanner, you can vary it all from 166 kilohertz all the way to 500 kilohertz. IP55 rated, and it has a standard 3-year warranty. It comes with SDR imaging. You can take 158 megapixel to 316 megapixel quality images. Comes with three integrated cameras, and even the lowest setting scan, which is done in 1 minute, you can the data is still very much usable, very much clear, and very sharp point clouds. So the software which we are actually using on the field on our controller or the Windows tablet we talked about is called as Trimble Perspective. So that allows you to see all the scans on the field itself and do all the registration on the field itself. You can use this perspective on an Android mobile or an iOS mobile as well, which will allow you to do the scanning via your mobile as well in case your tablet battery has died. And then we have another software, we can call it as Trimble. We call it as Trimble RealWorks and Trimble Business Center. I believe you already had one section on Trimble Business Center. So Trimble Business Center is your software which will allow you to do anything, whether it is your surveying applications or your mobile mapping application or your GPS applications, or even if you're flying drones, which we'll build on in the next seminar as well. So all of your data can sit in one single platform, and which will allow you to see everything all at once from variety of sensors, and it will reduce your requirement to go back and forth between different scanners at one time. So this is another scanner, which we call it as Trimble Sx12. It has a range of 600 meters plus, and it is a combination of a total station and a laser scanner. You can use it as a total station, you can use it as a laser scanner. Where the need arises, if you need one point surveys, you do one point surveys. Where you need a full fledged detailed scan, then you use the laser scanning in this. So there are three major softwares. Trimble Perspective is the software which is used on the field, which you are using it on your controller. It will allow the scanner control in field registration, dynamic 2D viewing, 3D viewing. You can add labels, you can add annotations, you can take measurement on field itself. And then we have Trimble RealWorks. So RealWorks is majorly oriented towards the industrial side of the things, wherein you can make 3D model of the steel, you can make 3D model of the piping equipment. You can do certain inspections also. Like for instance, if my a building is being constructed, my flats are being constructed, I, I want that it has to be a quality construction. So right on the field you can scan, and in Trimble RealWorks, immediately you will be able to identify that okay, if your floor is flat or not, if your wall is flat or not, if your ceiling is flat or not, and it will be done as per the ASTM standards. And then the final software is Trimble Business Center. It is industry leading survey software. Whatever you are doing on the field to generation of your deliverables, all it is an all-in-one software. It will be done in simple one platform, regardless of what sensor you have used. So we have Trimble Business Center. You can collect your field data. Here we can see that okay, we have the data from a drone, we have the data from from a laser scanner lidar, and we have the data from a GNSS. So all the three can be processed at one time. You can do your adjustment, coordinate geometries. You can do your CAD drafting as well. Since you have taken the surveying number of points, you need not take it to different software that, okay, now I will draw my lines there, I'll draw break lines there, I'll create DTM there and some other. So all your CAD and drafting applications would also be taken care in this here itself. Then we have surface and volume. So surface and volume is that okay, you like there have been certain stockpiles, you want to do the measurement, you can create a surface, you can create a contour map, you can measure the volume over here. When we talk of corridors, if you are doing a canal being built, you want to survey a road linear asset, you want to survey a canal, or you want to survey certain power lines. So all of your linear assets which will fall under those corridors, they also will be right from integrating the raw data to generation of final deliverables, they also will be taken care of in Trimble Business Center. Similarly, for data preparation, takeoff and mass haul, specialty applications, your 360-degree imaging or your drone-based applications, all could be taken care in Trimble Business Center itself. So Trimble RealWorks is again an add-on to our laser scanning, majorly used for industrial applications like plants and refineries. Same, it will do automatically process, register, colorize. You'll be able to analyze your scans, do the inspection, and you can generate a third-party in-depth reports. Or you can come, or for instance, if you have a design model earlier, or if you have an actual site on the field, you can do a design versus as-built collection. And whatever is your CAD, another program you are using, you would be able to export your data to that particular CAD platform as well. Now coming towards the scanning applications. So top 3D scanning applications we have tried to cover a little bit more could be building construction or facility management. Uh, like you'll be able to see. Now these days there is a different concept of co-working spaces as well. But how do you plan and optimize the space in your co-working? The things that when the building is in a base shell mode, you scan that particular building, you get it to your CAD or BIM platform, and then you can do a very precise planning that okay, what we have to do, what we don't have to do. And similarly, you'll be able to generate the drawings also. You'll be able to identify the facade. And another good thing which Trimble software does is that, say, I'll take the example of a building. If you have a scanned up building, you have the raw data of a point cloud. The software will automatically divide the point cloud itself into layers. The raw data itself will be divided into layers that, okay, these are my walls, this is my floor, this is my ceiling, this is my graded floor, these are my windows. If we talk of outside scans, it will automatically divide the point cloud data that, okay, this is my road, these are my trees, these are my light poles, or these are my buildings, or this is my noise. So from construction, right from breaking of the earth to actual doing the construction progress monitoring, how it is happening, if it is happening in quality or not, you can. The laser scanning is being widely used, and one very good example in India recently where this has been doing is a prestigious project which is happening on the Central Vista project, which is a dream initiative by the central government of India. So there, at least four of these machines are being used on an everyday basis. This is the verticality and the floor flatness analysis we are talking about. You have a site, you scan it, and right on field itself, you'll be able to identify that, okay, if your floor is flat or not, if your wall is vertical or not, or if you need to make certain changes, you'll identify that, okay, this is the area, this is my heat map. I need to make certain changes here so that it is precise. Then similarly, volume contours and inspection. After laser scanning, take it to Trimble Business Center and it will do architecture and facades. In architecture, this technology is widely used. In India itself, this technology has been used for the heritage conservation of Taj Mahal. It has been used for heritage conservation of Kashi Vishwanath Temple, Sun Temple, Konark, a lot of monuments in Delhi, like Humayun's tomb in Delhi, and even the Rashtrapati Bhavan. And the drawings which you are able to generate using this technology, they are dead precise. If you are into architecture, if you are into heritage conversion conservation, this is the technology which will give you always confident results. And you will be sure that, okay, what is there, you can do predictions what was there, because unless you have the good quality input data, you'll not be able to get a quality output. So that is where the laser scanning actually shines. So there are a variety of oil and gas applications, like in offshore environments, a lot of changes are continuously being made. So laser scanning is the solution to do a precise as-built 3D modeling for the same. You have your cross-country pipelines as well. Or again, when we talk of retrofitting projects, so in retrofitting projects as well, like generally, if we talk of shipping industry, their ballast water treatment systems um, have to be refurbished every year at times, or sometimes 2 years. So then, how do you know that, okay, there are a lot of vibrations, the ship goes through a lot of things, what changes have happened to it, what is the damage happened to my equipment? So then, laser scanning is very widely used over there. Certain other another oil and gas applications could be process management, retrofit revamp, and you can use it for dumb modeling. You can use it for your intelligent modeling, and for tanks, it is we have you know that by law the tanks have to be calibrated every 2 years, every 3 years, sometimes every 5 years. So for tanks, this is the perfect application or the perfect solution to have. It will automatically classify your tank into the shell, into your dead wood, into your remaining data, and do a volumetric comparison for you. And not only volumetric comparison, volumetric calibration, it will also tell you that what is the settlement, what are your sump volumes, or how your surfaces are looking, if it is a floating gap, if it will float perfectly or not. And so a full-on inspection also it will do that, if what is the verticality of your tank, what is the roundness of your tank, or if there is a tilt in your tank, or what is the level of tilt, or what is the slope if it is a horizontal tank. So all these things it will do in an automated manner. So these are some examples of industrial outputs wherein full plants have been made into a 3D environment. And the software Trimble Railworks, what it will also allow you is that what up to 70% of the pipes which you have laser scanned, it will create automatically without any human intervention. You simply press a button and it will generate the piping for you. And similarly, it will auto segment the steel beams as well with the standards that, okay, if it is your medium beam, if it is your heavy beam, if it is your light beam, what is the IS code for that? It is smart enough to find that automatically and do a 3D, full-fledged 3D model for you. This is again for facilities modeling. So there is one application which we wanted to show. This is a topography plus bridge. And so here the equipment which you are seeing is the new one, Trimble Sx12. So what this will allow you to do is that it will allow you to take a traditional survey as well as do a laser scanning all in one place. And if your area is vegetated, I mentioned that it will automatically classify your vegetation as well, and not only classify if your trees, it will also find out what is the height of the trees and what is the girth of the trees on its own. So then your application might be in civil infrastructure. You can do monitoring or you can do tunnels. Now there a lot of tunneling has been happening in India lately. You want to do your drafting, or you want to do prepare a topo map, you want to prepare a break line. And this is one example wherein we have one platform called as, which we call as Trimble Clarity or Trimble Connect. You can do is that you can share a project with a number of people, and those number of people can comment on that, so that all the people who are working on this particular project, they are connected and there is no disconnect or communication gap happening. Certain heritage applications we have talked, you can use it for forensics, and forensics also in India also the laser scanning is being very widely used. You can use it for your railway inspections, track alignments, mobile mapping, linear asset surveys, corridor surveys. And Trimble X7 can literally go anywhere, and you can see that you can tilt it to up to 45 degrees. You can use it in a confined space. We have mounted it on a robotic dog, or we can use it in an upside down manner as well. So the applications are endless for this, and it is a really fast solution for you to actually uh, enhance your surveying business and vastly enhance your surveying efficiencies. Uh, so I have got one question from Abhishek, that what is the level of accuracy Trimble X7 can provide during bad weather condition like rain showers or low visibility? And same for Trimble Sx12. So when we talk of low visibility, Abhishek, it will not affect us, and the overall accuracies we would be able to find out in the we would be able to find out right on the field itself, and we can get accuracies in millimeters, 1 millimeter, 2 millimeters. Your room could be dead dark, there could be no light in that particular room, visibility could be zero, and it will still do the perfect laser scan because the laser will still strike the object and come back. And in rain showers also, like we were talking mild showers, if it is heavy rain I'll not recommend. But at the same time, if you are doing it in say a mild shower, as long as the rain droplets are not thick enough to scatter the light, the accuracy will remain the same in the range of 3 to 3.5 millimeters. And similarly for SX12, SX12 scanning can happen in low visibility as well. But since SX12 is also a total station, if you're using traditional surveying using a prism, then it struggles in low visibility. I have another question. What are the risks involved with laser scanning technology, and can those be minimized with the Trimble X7? So I'm not sure, Mohit, if I got your question correctly, but risk involved is that majorly I'll say that the risk involved is if you have a significant project, if you have a significant asset, the first step involved is actually not to laser scan it. And when you are talking of a precision level of surveying, which you have, wherein a lot of details matter more, then at that time I'll say that all your risk would be minimized with using the laser scanning technology itself. And Trimble X7 will allow you to do your or to capture your data a lot faster, because all of the applications which or a lot of the part which you'll traditionally do in your office, that certain basic measurements, doing your stitching all your scans together, georeferencing all your scans together, that will be done on field itself. I have a question from Archita. What is the scan duration of X7 and SX12? So Archita, depending on the number of points which we want to collect or how dense we want the data it to be. So for X7, we can do the scanning in 1 minute all the way up to 15 minutes, and it will take photographs as well, so that your scan data is colorized. When we talk of SX12, SX12 takes a lesser number of points as compared to as compared to X7, because it is a combination of a traditional total station and a laser scanner. And for SX12, the scan duration will go from 5 minutes all the way up to 1 hour. I'll encourage you ask to ask as many questions as you want. Uh, so at the same time, like if other questions are not coming, I'd like to emphasize little bit on the webinar which is going to happen now as well, which is going to happen on 29th of September. So that webinar also focuses on Trimble Business Center, but a different module. So the Trimble Business Center has a variety of modules, like you can, as mentioned earlier, you can use it for your CAD drafting all the way to your drone imaging. And when we talk of that drone imaging, a lot of UAV-based projects have been supported by Government of India and Survey of India in Swamitwa itself. So, like drone, you can fly any drone. Data collection with the drones is the easier part, but how you are actually using the data or how you are actually making those images usable is very important. And so that next webinar will focus on that, and you will be able to see that okay, it is just one software which is doing everything. Okay, I have one question from Ashish. Can I develop tool for survey related application support customization tool? So Ashish, we support after the data is captured, we support after the data is exported either in LAS and all, we support macros. You can write macros for that, and at the same time, we do have a certain Trimble program wherein we allow certain customizations as well. Archita, does both X7 and SX12 support cloud-based registration of data? Yes, Archita, both support cloud-based registration of data, both support target-based, sphere-based, and at the same time, both support the total station-based registration of the data as well. And when we talk of this automatic registration, Archita, which was happening earlier, so this automatic registration majorly happens in a cloud-based environment only. But if you have pasted the targets, the software will automatically identify the black and white targets for you as well, alongside spheres. So, and if you have more specific questions as well, I'll encourage everyone to that you can write to me over the email as well. I'll just quickly show my email address once again. I hope everyone can see that as well. So Sneha, she's laser beam footprint size at the range of 50 meters. Right now, I don't remember it at the top of my head, but you can write to me. I'll definitely get back on that. But to add on Sneha, what I believe is that in this laser scanning, we do have the largest size EDM, so it should be fairly precise, but I'll definitely get back to you with the correct figure. Yes, Rajendra, that's a good question system, graphic card and RAM for processing the data. So Rajendra, what my recommendation is that I recommend at least get an i9 or Intel Xeon based processor. Uh, should be a multi-core processor, and I recommend a RAM of at least 32 GBs, and preferably at least a 4 GB graphic card in NVIDIA Quadro series. If we can have an NVIDIA RTX based graphic card which will support the ray tracing as well, that will be more fantastic. but minimum 32 GB RAM and 4 GB of graphic card alongside a multi-core processing, preferably i7 or i9. So, all right, everyone. Thank you so much for your time. For your time. I hope you all were able to learn something, and I'm looking forward to your emails as well. I'll encourage you, all of you, to bombard as many questions as you can, and we'll work together to find out that okay, what is the solution we have, and to present the right solutions with you. And so, let us conclude it over here. Thank you, everyone.